Hi, Pavel. The question is, what was your first computer?
Well, my first computer was Pentium 1, actually, because I'm pretty young. So it was the machine I was playing Duke Nukem 3D on.
Hmm.
And it was a second-hand machine. And at the time, it was already like 5 years old. So that's the very first machine I owned.
How old were you?
I believe when I got my first very own PC, I was like 12.
Okay. And which Pentium was it? So you remember the speed?
Yes, yes, it was 75 megahertz.
Ah, I had
That was the
exactly the
best.
same. I had exactly the same. I think there was one before with 60 megahertz, but I got already the 75.
Yes, well, at the time, I didn't really care about the speed. All I wanted to do is just to play the games, and it could handle them really well. So,
Yeah. And you just use it for gaming all the time, or what was your road to first Hello World?
my first Hello World was actually much, much, much later, at the age like 17, when a friend introduced me to programming. It was a trial and error approach. Basically, in the very beginning, I was trying to hack some HTML first, then I tried some JavaScript, etc., etc. But that was still the age of every website had a clock, so
Okay.
it was still amazing time to start developing. So that was my first Hello World, I believe. I really remember it really blurry.
Which year was it?
2005.
Okay, so it's early for the, I would say, somehow early for the modern web stuff, right? And about your friend, so did your friend force you to program, or you had interests, or why you started at all?
Actually, he just showed me because at the time nobody ever showed me how to program a computer. I had no formal education, and he was an online friend at first, and then we met
Hmm.
in Prague, in Czech Republic,
Hmm.
and we spent like half a day when he showed me some programming stuff. And at the time, it was really magic for me, and I really wanted to do this. I
Okay,
really badly wanted to do it. So this was my first steps.
so it was your online friend. So so you met for gaming with him, and then met in
Yes,
Prague.
yes. We met.
Okay,
We met in a game. It was Quake 3 at the time.
okay, okay, cool. And then what happened? So you started hacking JavaScript, or I mean,
No, actually, then there was a big nothing for almost 2 years, let's say.
hmm.
And then after high school, because at the time I was on high school, or I just entered high school, and the high school was mostly about economics and modeling, and there was no computer science at all. But after high school, I decided to join the same faculty, the same university as this my former friend who introduced me to computers and programming in general. And then I joined the very same faculty and started with computer science from scratch.
Ah,
So
so you started twice.
yes, yes, I had to start twice basically, but the second start was really quick one.
Uh-huh. And could you skip, the first part? So in Germany, what is sometimes possible? So if you study the second time, you could skip, I think, the first 3 semesters because it's like, the base stuff. Could you skip something, or you had to know to redo
Oh,
everything?
no, no, no. Sorry, that's a huge misunderstanding. Actually, I had to start twice because on high school I had no guidance and he just showed me some stuff. I was still experimenting, but internet connection was not available all the time at the time for me. So I just fell behind. And after high school, I joined a university
Hmm.
and then I started again with proper guidance and with proper education.
Yeah, sure.
So
But you studied first, business, and the second time computer science, I guess, right?
no, the business school was high school. College
Ah,
was
okay.
computer science.
Ah, very good. So you studied once computer science. Okay, now I
Yes,
got it.
yes.
Okay, cool. So you're a proper educated, informatic guy, right?
Yeah,
Yeah.
hopefully, yes.
Yeah. And which university was it? Was it in Prague? No.
No, it wasn't in Prague. This was a much smaller university in Hradec Králové. That's a city in Czech Republic, and it was Faculty of Informatics. So the whole faculty was dedicated to computer science.
Hey, cool. So and then you started proper programming, right? So now you started from scratch. Really learn.
Yes. Then I started properly with the theoretical stuff first, which I really enjoyed.
Oh, really?
I found myself in it. Because the whole course, the computer science course, is much more about theory than about coding, which I still like it. I used to like it, and I really found myself in this area. So I started with Java. That's what I remember, but we went really deeper and much more low level afterwards.
Which version of Java was it?
1.6 at the time.
Okay,
1.6.
cool. So you already had the chance, to start with annotations and generics and the newer stuff, right?
Yes.
Cool. So what was your second Hello World? So the first one was hacking a HTML page. So what was the second Hello World? I assume with Java, right?
No, in the middle there was a game. It was a Czech game actually, Operation Flashpoint, and there was a scripting language inside.
Uh-huh.
And
what was it? Lua or what scripting language?
No,
was
they
it?
had their own version of.
Okay.
It was something in the middle of between C and JavaScript, I would say.
Okay.
So it was really nice to play around with the game. So that was my probably second Hello World before the college.
And what you could do with the game then? So I mean,
anything. You could rotate a tank like a helicopter. You could do anything. It was really powerful.
Okay. So you could remote control the game, so kind of, right? So there
yes, you could script missions. You could script the soldiers, the so-called AI at the time. You could do anything.
Okay. So then were there like functions available already, or was it like just a pile of code?
No, there were plenty of functions available, but some of them were still missing or provided by the community. So it was part of the fun, actually. If you don't do it for money, then you just want to create a lot of stuff on your own. So yeah, there was a lot of prepared functions in the game already, but the game at the time was, I would say, out of maintenance. So we had to do a lot of things on our own.
Was it a kind of open source game?
No. It was never open source, as far as I know. It was a commercial product. Pretty successful, I would say.
So what was then your third Hello World?
That was definitely the university. That was the proper Hello World. That was a Java program. And, it was a register for cars, I would say. It was a project in the very first semester we had to create. So I believe I still have the code somewhere.
So was it client server? Was just client? What was it?
No, it was a Swing application. It was a desktop application. And the main point of it was to introduce the students into object-oriented programming. It was the very beginner's course.
Okay, and you like that?
I really like that.
Hey, cool. And what was your first, server-side experience, also at university, or?
Yes, in the third year, we had a proper introduction to enterprise Java.
Okay.
And I really liked the concepts because it was, again, taught really in a theoretical way. So we learned how it's all based on servlets, how servlets are the basement for everything else. Okay. So yeah, that's how I started with Java EE. And then long story short, I grew up on people like you and then others.
So it seems like at the university, you had lots of fun with your professors, or you had good profs, right?
Yeah, it was a small class, rather small. Actually, there were like 150 people starting and properly finishing 8. So
it was exactly the same in my case. So as I started, there were 180 students, so there was not enough room for all us. So I remember I was just in the corner, I couldn't see anything. And at the end, we were no more than 15. So I think like 12 students. And there was an extremely small group. So this was interesting, actually.
Yeah, I believe some people actually finished the school later, a little bit later, 1 or 2 years, but I'm not really in touch with them, so I have no idea. But properly in time, there were 8 people finishing.
Okay. And what was your first project, enterprise project at school?
I am not sure if I remember that. The very first one was probably some semestral work, so not important. It was all based on servlets, and we were creating some basically just experimenting. That was it. But my first commercial project, that was for a company in Prague, and I was hired. It was my second job. And we used, at the time, we used Java EE 6.
Okay.
And it was a backend for a banking company. And the backend had to pump data from the database and send it via REST API to mobile devices.
And which server was it?
At the time, they had WebLogic.
Okay. And which year?
I have no idea. I don't remember.
But it was like 2010, I suppose, or 8 or something like this?
I believe it was, yeah. You mean the year I did this? Or the release year of the WebLogic server?
Okay. But it was after your university. So for me, it's interesting.
No, it was during university.
During university. So you did your commercial projects during your study?
Yeah, of course. Actually, I was working full-time during the last 2 years of my studies. So it was it was hell on earth, but...
Hey, I had exactly the same experience. So I studied full-time during, I worked full-time during my study. It was hell on earth, and I was so happy that my study, I tried to, study as fast as possible, to shorten the hell a little bit. And then I was really happy that I just have to work, because doing both at the same time was terrible.
Yeah, you just don't have time to do both properly. So yeah. That's exactly or almost exactly the same story with me, except I really like the academia. So I try to stay there for a little bit of time more.
Okay, cool. And so you used Java 6 with WebLogic, and you started study when? Which year? 2005, you said?
No, that was high school. So I started 2010. There was 1 year between high school and college where I had to work.
And you studied 4 years?
No, 5 years.
5 years, so 2015. So someone in between, you started your first commercial project with WebLogic, Java 6, and JAX-RS, right?
Yes, there was JAX-RS involved.
And was it successful or not?
It was really successful, of course. It wasn't. So how can you go wrong with JAX-RS?
I mean, I had as I perform code reviews from time to time, and sometimes I see JAX-RS projects with, no kidding, I would say 3 layers of empty stuff, just mapping back and forth without any additional, added value. So a lot can go wrong if you are not, pragmatic.
Oh, really? Okay, that seems like a sad story, but at the time, actually, it was my infrastructure, and I, as an experienced student, I was inspired by some other projects from Bitbucket at the time, and I basically learned by experience. So I did a lot of mistakes in the very beginning, which was 2 or 3 weeks, and I had to rework a lot of stuff, but then I ended up with just 1 layer at the REST API layer. At the JAX-RS, we had our own DTOs there because they could change, of course. And then there was only one DTO from the database and mapping between it. And of course, some logic. The project was not only about mapping, but there was a lot of business logic added later. But yeah, it was simple as that.
Yeah, it was always productive, so your client were happy.
Yeah, the project, the very first version was finished in 2 months.
Was it good, right? So, I mean, it could be.
Yeah, it worked really well. There were other problems on the project, like the API on the bank side changed a lot. So, but that wasn't really our fault. And because the project actually had one big advantage. Later, it was transformed into Java E7, which was no big deal, but I wasn't at the company at the time. I was just consulting for a few weeks there. And what we did was we involved a project called Enunciate, which generated the REST API documentation for us completely for free. We just made it a part of the Maven build. We used Maven at the time, and it was really for free. So every change was documented right away for the mobile device developers to embrace it, and that was it.
Yeah, Instantiate is still interesting. So it's actually a great little open source project.
I have to admit I haven't used it for a year maybe, so I'm happy it's still around.
Mm-hmm. Cool. So, and how you proceed from that? So this was your first project. Was the next, or what you did then? So the first was successful. It was Java 6 at the bank. So what you did then?
Then I changed my job, actually, because of money, of course. So I felt like more senior, let's say, and I was happy to join more of a challenge, I would say. So then it was mobile development again, but for a different company. And basically we have been building backends in the very same manner I've just described, but it was more challenging. It was bigger projects. The schedule was tight. And then on my project, I used Java EE, and then we used a lot of Spring on the other projects because I wasn't the only developer in the company.
So what was your experience with both? So you started with Java EE and then you did Spring. So
I actually always preferred Java EE, especially at the time because I had no experience with what some other people call as old, fat, obsolete enterprise Java beans, and you had to create like 5 classes just to make some business logic happen. I jumped on the train when Java EE 6 was out. Java EE 7 was almost out at the time, or almost widespread. So I used that, and the experience was flawless for me. And for me, the key, the most important stuff in Java EE was CDI and JAX-RS. And that's what made me jump on the Java EE train, because CDI was much more developed at the time than Spring. Spring was still really cool. It had some cool features. Java EE had its caveats also, but CDI and JAX-RS were the strong foundation for me as a developer, because at the time I didn't really understand the internal mechanics. Yes. So I just used Java EE, and it was far more simple for me.
So that's actually interesting because,
and it was lighter. It was lighter, and it was faster to work with. I didn't have to.
Okay, how long? This is interesting, actually. How long did the average deployment took in your experience, and why it was faster than Spring, or how fast or slow was Spring?
Yeah, Spring was extremely slow. It was like half a minute to start. The Spring projects we had, it could be done better. So 50% of the failures there was just inexperienced developers or stupid developers. That's why I quit the company a year after I joined it. But I just said I'm no longer doing it, because these people were pushing me into these Spring projects, and when I did a change, I had to reload it for half a minute while redeploying on Wildfly, because I was using Wildfly at the time. That was my architecture, so I just chose Wildfly because of the lazy loading and of libraries into memory. It was really lightweight, and it took me, if it was a JSF project, because we also had websites, so the JSF took over a second. And the redeployment of normal JAX-RS API project, if you don't count the building phase in, was under a second, definitely, maybe half a second. So before I could switch to the browser or switch to Postman, which is what we used at the time, it was already redeployed, and I could just test it. That was it.
This is also my experience. So, my project is a little bit slower. So the projects are bigger. So it takes usually at most 3 seconds, I would say. And I get lots of questions, conferences, which tool are you using, and deployment is slow. And it was actually never slow in my case. And I don't use anything. And it's just fast, out of the box. And therefore I ask you the question, because it cannot be that I'm the only, with a guy who has fast deployments and all others, struggling with the slow stuff. So, sorry, go ahead.
Yeah. Well, my experience is same as yours. We had a 180 megabytes web archive with Spring inside, deployed on Tomcat, and it was hell to develop. It was hell to deploy. There was a log of, thousands of lines before it even started, with no real value inside. And then I had this Java EE project nobody liked at first. Then a lot of people started to like it. But then everybody was skeptical, and in the very first beginning, and they were like, "Oh no, we are going to use Java EE, but that's so fat and obsolete and so slow." But I was young and stupid, so I just picked whatever worked best for me, and it worked.
So you were not that stupid. You were probably young, but more pragmatic. But how big was your war?
My war was few hundreds of kilobytes, but the JSF projects were bigger because there were some images and graphics inside, so that was over 10 megabytes.
Okay.
But cool. The code was hundreds of kilobytes.
And the developers liked the Java experience afterwards? Or what was, some developers transitioned to Java EE, or what was the story then?
Some of them liked it. Some of them even transitioned. And some of them, no, never. So there was a huge war.
Okay.
War of frameworks. And then I said, okay, I quit. I don't care.
Okay. And the project was in Prague?
The project was in Prague, partially, yes.
Okay. Okay. And then you quit the company, and you were still at the university, right?
Yes, it was about time. Yes, I was still at the university. I was still a student.
Uh-huh.
So, but I was about to end the education. So I remember implementing one of the bug fixes when I had the final exam, like the really big one, and they decide whether you're a pass or you're a failure. So I took a 2-day off vacation. So I passed the exam, and then I finished some final work, and then I quit.
Okay. Okay. So then, what happened after university? Were you a freelancer? You joined another company? So what was the story then?
Then actually I wanted to do Java EE, but I digged really deeper because then I started to have time with the university finished, and I also joined a little bit of a PhD. So I continued with statistics. I had a lot of interests, but I really wanted to continue with Java EE because it helped me every day in my life with being so easy to use. Mm-hmm. So I found a new work. This time a good one, I would say, and the team was really a good match. It was also in Prague, and we had a nice time for like 2 years.
With Java EE or without?
It was Java EE. Yes, it was Java EE.
And proper Java EE, I mean pragmatic, small wars, thin wars, fast deployments, or just a crazy project, with endless layers in superfluous framework. So it was the pragmatic Java EE, I assume.
It was the pragmatic one because we were creating mostly new projects.
Cool.
When I joined the company, I was given the opportunity to start a new project for one of the customers. So we created it exactly like that.
And what kind of business logic was it? Was it bank again, or what was it?
No. It was telco this time.
Okay.
It was about SIM cards. It's as much as I can tell.
Okay, no, this is enough just to know. And by the way, your experience is consistent with experience I get with fresh developers. So right now I help a few startups to be successul, or to coach a little bit. And what they ask me constantly is why Java EE is so productive and so fast. And the cool story is they don't care about the Java EE internal stuff. They just use what I show them, and you only need a little, JAX-RS, a view CDI annotations, actually one CDI annotation if you build backend, and then a little bit JSON-B, sometimes transactions, and you are ready to go. And they just run, stock whitefly without any configuration. And it is fast enough. So there was never trouble if you are pragmatic. So it seems like you had similar experience. So
yes, actually, that's exactly how I did it. Stock whitefly. That was the perfect starting point for us. It's easy and fast to start, and without any configuration at all. If you have JPA, then you have to apply some drivers, but it could also be automatized as well. So it was really quick to start with.
Yeah,
I had the same stack, basically, same stack.
Yeah, cool. So, and the sim project, you had fun for 2 years, and then what happened? So the project was
then
stopped?
The project was ended. So This time it wasn't my fault. And my boss, actually, his name was Martin Schmatt. So Martin, if you're listening, then thank you for the good time. And our project was stopped, and I went to some other company.
And still, It's Java?
Right now, it's machine learning.
This is the current company and before.
Yes, this is the current company. And
there was nothing in between?
No, there was nothing in between.
Okay, so what's interesting, I know you a long time from various sources. So when we met once in Prague, it was like, I think, Oracle Code Conference, and I delivered a keynote. So we had some funny moments there, and I had no opportunity to talk with you. But before that, you pinged me several times. So when we met, the first time in virtual space or in internet, so you remember that? So you sent me a tweet or whatever. So we are in contact for a long time already, right?
Yeah, actually, I was a close follower of your tutorials and your videos.
Okay.
At the time, after university, I really dug deep into Java EE, and I kind of started to reverse engineer it. Mm-hmm. So I was looking what's under JCP, and I really wanted to get it. So I started basically exploring a lot. And your tutorials, videos, and not just yours, people like Reza Rahman and other people really produce great content out there. So and I believe I had some questions for you on Twitter. I don't really remember if it was Twitter, but I sent you a question about something, and you helped me out.
What I think, what it probably was the AirHacks TV.
Probably, yeah. Yes,
this is the monthly YouTube show, which I usually do. This is the first Monday of the month, and then I know. So you ask, frequent questions, and I try to answer them. And this is how we are in contact. So the next time was the Oracle Code keynote, where I was invited, and I just hacked all the time. And by the way, there were some people from the keynote joining the Java user group in Prague, and still remember the keynote. Say they expected some slides, and they just only saw code. And I did something with the Czech Kritek. It's like this small creature.
Yeah.
I remember.
Yeah, I remember the small creature.
And that was lots of fun. And how? So you studied in Hradec Králové, you said, and you had
yes.
And you had to travel to Prague.
And I was working remotely.
Remotely. But how far is Prague and Hradec Králové?
That's 100 kilometers, but there is a highway. But we don't have unlike in Germany, we have a speed limit here, which I didn't always obey, but
yeah. And,
don't tell anyone.
No. How fast can you go? 120 kilometers per hour or 130?
No, 130.
Yeah, this is the same as in Austria, I guess. So it's not a big problem. And by the way, all the speed limits, do not work anyway, because in Germany you could, in theory, go fast, but usually there are lots of roadworks, so it actually doesn't matter. You always probably your average speed is around 100 kilometers per hour. So regardless how fast you go, so it doesn't make any sense to go faster than 130. But why I'm asking. You asked me to come to visit your Java user group, and I always said no. But we have to fix this one day. So if you have a Java user group in Hradec Králové, 100 kilometers is doable. So I can fly to Prague and then visit you somehow with a car. So if you have something there, we can manage.
Yeah, I'm still in touch with the university. So they would be happy.
So we have to do this. So I promised you this 2 years ago. And I have so this autumn or next spring we could do something if you still like.
Yeah, of course.
Yeah, so let's keep that. So now you switched the company. So your first Java proper project was over, and now you switch to a company which is really interesting because the name is H2 something.
H2O AI.
H2O AI. Is it a Czech company?
No, it's a Silicon Valley startup.
Cool. And
it's much less of a startup than it was almost 2 years ago when I joined the company, but it's still not a Fortune 500 company with thousands of employees.
So first, how you found them?
Well, that's an interesting story because one day, usually you get a lot of phone calls from recruiters and they want you to join your company now. And I believe everybody gets thousands of them per day. And I got this really interesting phone call from a recruiter, and I don't know where she got the phone number, but somehow she called me, and she really perfectly hit the very day I was told the project was ending. My project was about to end, and we were told at the very same day. And they said I was doing some PhD stuff at the time with statistics, and he said, hey, there is this Silicon Valley startup and they are doing machine learning, which is a lot of statistics involved. So that's how I joined the company. I evaluated some other options and this one was simply the best. So that's why I joined them.
Cool. And there's a Silicon Valley machine learning startup and you are still in Hradec Králové.
No, I'm based in Prague actually right now, but it's very difficult with me because I have part of my family is in Germany, or near the German borders, so I travel there a lot. So
okay.
I'm a distributed employee.
Oh, okay. So you are distributed. Uh-huh. So not cloud native rather than
yeah. We do have an office in Prague.
Mm-hmm. Oh,
quite a big one actually.
Okay.
So they started an office there, and we have I believe almost 40 employees right now, but I might be mistaken. But it's actually a lot. And the main HQ is still in Mountain View.
Okay. So, and now what's the deal? What they are doing? I mean, what is, what would like to the company achieve, this H2O?
Actually, there is a funny story to how the company was created, because at the very beginning, it was just a distributed, or just, quote unquote, just a distributed key value store. And one interesting fact, there was Cliff Click involved, the creator of JVM Hotspot. And one day they met a company which required some machine learning algorithms on top of this DKV. So that's how H2O was created, was found. And since then, it was several years before I joined. And what we do, basically, we have actually everything we do is open source. Let's mention this first. So you can find us on GitHub. Just look up H2O and then you will see the open source stuff. And we do machine learning algorithms.
Okay.
On a really big data. We have a distributed system. That was the short answer. We have a distributed software application system, call it however you want. And it does in-memory computing. It's basically a really fast platform for in-memory computing. And it's a really general platform. And on top of that, we implement machine learning algorithms.
Okay. And everything is open source, and how the company would like to earn some money?
We have one product that's not open source. It's called Driverless AI. And that's actually paid from scratch. And then, of course, you can pay for support and for consultancy as well.
Yeah, and what is the added value of the driverless AI?
It automates some stuff you have to do manually with the open source H2O. For example, feature engineering.
Okay.
It's able to do a lot of stuff for you, do the space exploration for you.
So it increases the productivity by, auto-adjusting the features or training models or something.
Yes, exactly. It's much more than that. It integrates knowledge of a lot of Kaggle grandmasters we have, and we have a lot of recipes there you can use to your advantage, and you would have to do this on your own with H2O open source.
So the algorithms, are there, written in Java, or what language?
Yes, it's the heavy lifting. All the heavy lifting is completely written in Java, because the machine learning world is a world of statisticians and maybe managers and data scientists, of course, And these people are not all the time primarily coders. So they use Python, they use R, maybe some other stuff, but a lot of them don't know Java. But Java is, as Cliff said once, fast enough. So we do it in Java, and the Python client and the R client is just a really, really thin, small client. And everything is a REST API call, basically.
So typical algorithm implementations. On which algorithm are you working right now? Or what are you doing right now? If it's open source, you can tell it probably.
Yes, of course. We have a lot of them. We have, of course, supervised, unsupervised algorithms. We have a lot of tree-based decision algorithms like GBM. We have XGBoost integration right now. That's it's not that fresh, but it's a year ago, I would say it was stabilized. I might be lying, but we have isolation random forest. We have normal regression, GLM. We have even old algorithms or simpler algorithms like naive bias prediction.
Okay.
So
So, and how this is implemented? So the algorithm is implemented with plain Java SE. So it's just, plain Java classes.
Yes and no. Actually, there is a REST API. So there are servlets and pieces of Java EE as well. But we don't use dependency injection inside. And I would actually think as the platform as the 3 layers, 2 or maybe 3. One is the REST API itself. And it's one big. It's actually pretty small. It starts under a second on my machine. And it's really a pleasure to develop it. But it starts under a second. And then there is this REST API starting. Then you have this distributed key value store with the distributed computational platform. And on top of it, there are classes with the machine learning business logic.
So your algorithms are somehow dependent on the distributed key value store, right?
Yes.
And is the API a map, Java util map, or something different?
I'm not sure I understand.
So if you use, for instance, Hazelcast or Infinispan.
Oh, I see.
So what will happen is your API is more or less concurrent hash map, and the implementation comes with Hazelcast. So what interests me, is it the same in H2O case?
No, H2O has its own implementation of everything. That was actually made by Cliff a long time ago, but not just him. And what he did was he optimized everything for speed. Because as he was the author of Hotspot, so he knew how to do it. So we have actually our own distributed hash map, which is optimized for speed, for reading. And we have our own serialization.
Yeah, but the hash map, I would like to use, the key value store, could I just, use the Java util map interface and your implementation, or you get another interface,
Yes, it's compatible with Java util map. Yes.
Okay, so this is actually great news. So what it means is my algorithm is not that dependent on your custom implementation. I could just test with regular hash map.
Yes, you could do that. You could do that.
Yeah, cool. So now it becomes interesting because, this is like a really interesting company. Everything is in Java, so it's very easy to test. You can clone, your GitHub repository, play around with AI, right?
Yes, we do have a lot of unit tests there, among other tests as well. Once you clone it, there is no application server, because how we did it is that the application itself contains only the pieces of Java EE that are necessary. So when it starts, it only starts servlets and a bunch of other stuff, and the other is just plain Java SE process.
Yeah. In your case, I absolutely get it, because you don't need, most of the features. You only need POJOs with REST endpoint. And by the way, what you should do one day, you heard about Quarkus?
Of course. I was evaluating it, and now I'm using it on one university project.
Yeah, because it could be really interesting for this, because it does exactly that. It comes with just JAX-RS and CDI and nothing else. And you could even create, your own extensions, which will do with the algorithms, which are pre-compiled. And then at runtime, you only will get, a more or less, it would look like a Go library, it's just a native image without any external dependency. So it will even faster than now. But but if you know it, perfect.
It could be really interesting, but at the time H2O was written, there was nothing like that.
No, but now
it was 2012.
You could wrap it, because in a few weeks ago, what I did, we had a proof of concept. So I migrated, a Java E project to Quarkus, and it also worked. So it was not a big deal.
It usually works out of the box almost.
Yeah, we had some issues, all the drivers and stuff, but it worked regardless. Okay, cool. Now, because you are, the unique mix of Java knowledge or Java knowledge and AI. So let's say I have Prometheus or MicroProfile matrix from my system. And I would like to, to use your library, machine learning library, to find some, let's say, anomalies. So like stuff which behaves strange, and which algorithm or how to achieve that. So I will collect the data. This are my microprofile metrics. I could collect them every second, and then use one of your algorithms or libraries to find, strange things in the behavior. So how to do that? Or which algorithm to choose? What you will suggest me to do?
Yes, the short answer is IRF, Isolation Random Forest. That's a great algorithm for outlier detection. So this is the one you could use. That's the short answer. The longer is you would have to save it, probably transform the data a little bit, evaluate it. If it's what would you get? Just save the data was time series. So you would first, with H2O, had to transform the data a little bit. I would say maybe clean them, check how many missing data you have, etc., etc. All the proper stuff a data scientist would do, and then just start H2O and start the algorithm inside H2O, and that's it. Then wait for a couple of minutes based on how big your data is, and that's it.
Yeah, the time series data would be already available because it's a part of Prometheus, and it comes with InfluxDB, I think, internally. So there is already, the database available. So this would be not a big deal, right? So I could just,
with H2O, this wouldn't be a big deal, and we also have JDBC connectors as well. So you could just provide the driver if it's really a non-standard driver. Otherwise, we are able to bundle some of them or handle some of the JDBC connections out of the box. And then you would just pretty much specify your SQL select statement, and it would be imported into H2O.
Okay. And what was the name of the algorithm?
IRF, Isolation Random Forest.
And this is the name on GitHub. So I will search for IRF H2. I will find something, right?
Yes.
Cool. And do you have also something like, I forgot the Python library, you can recognize vision recognition, like, for instance, you can train to recognize people on pictures or something like this?
No, we don't do that, actually.
Okay, why not? Because it's out of scope, or it's not needed, or?
Right now it's not needed by any of our customers, I would say, but I don't have the full picture right now as a developer. We do have a lot of customers, so maybe there are some requests, but the main use case is big businesses, insurance companies, banks, and for some reason there is no demand for that right now.
It's called OpenCV is called, right, in Python, I think. This was the imaging.
Yeah, OpenCV has a Python API, but the implementation, I believe, is in C.
Yeah. Exactly. So there's nothing equivalent. Okay. No worries. And
no, we don't do OpenCV right now.
So which other algorithms might be interesting, for a Java application? Something cool. So what I could do with it?
That's
cache hit. For instance, I have a cache, and I could use AI, to predict which data should stick in the cache and which not.
Yeah, this could be a really good fit for some tree-based algorithm like GBM.
GBM one, okay.
Or XGBoost, but GBM is the most used algorithm we have, by the way. And
okay. For what use cases? So for what?
Actually, you can use it to predict almost anything. If you have a binomial, multinomial response of any kind, or you do regression, then you can use it. It's just a matter of organizing your data well.
Okay, so give me some real-world examples.
Real-world example is predicting. I would say the best example is on Kaggle, the famous with the famous data sets like airlines. So you can predict airline delay on departure or you can predict cancer remission.
Okay.
You can actually you can even score comments, for example, on Google reviews, and let's say filter out the bad ones or spam.
Okay. So what we could do, as just listening to you, is for instance on application servers there is a incoming queue. So this is the processing queue. And if the queue is full, then some timeout happens. So this is actually a simple correlation. But what I could do is to use the algorithm and monitor the incoming queue and predict when the server breaks down, right?
Yeah, let's ask ourselves. This is perfect example for GBM. At least it looks like it. Let's ask ourselves what features, what predictors do we have here? So you have the request, which has several attributes, like the type of request, where does it come from, what's the current load status on the application server. Maybe you even have information about the hardware resources available, right? So what else? What else?
Yeah,
Maybe.
the incoming queue, the processing queue is probably the most interesting one, because this is if the queue we know the capacity of the queue and the total capacity, and we know the current state of the queue. So this is interesting. Then
in this case, it would probably depend on time heavily. So this is really like an artificial example. So the most explanatory feature or the variable with the most importance would probably be time.
Okay.
Because patterns can be observed if you run a service, like, I don't know, some REST API providing some general service, then time is usually the explanatory variable.
So the processing time, you mean?
No, the time the requests come to your system. Because you wanted to, if I understand you correctly, you want to predict the load of the server, right?
The load, and more interestingly, when the server breaks down. So because what I know is if the queue becomes full and I get still incoming requests, in one point of time I get timeouts. So in this particular case, I could use the algorithm, and actually with Prometheus I could do this. I think the algorithm is called linear prediction. So I have the depth of the queue, and I know if it becomes full, and on this if it grows over time, and on this rate it will probably break down.
This is a very simple.
Very simple. So I thought
way to predict.
Yeah,
but if you are able to put more information inside the algorithm and use something more advanced, for example, the GBM, the general algorithm, and if you can feed it with more details, like the type of the job that's actually being done right now, then you can more easily, more precisely predict whether it's going to fail or not.
Yeah, what we could do, for instance, what we would have on application server is the JDBC connection pool state. So how many connections? Then what we could also do is if the microservice talks to another microservice, the processing time of this connection. So this we'd also get for free. And we have the processing time of the JAX-RS. So you could gather a lot of features.
And maybe you could even categorize the requests into at least few categories. Or maybe you could do it multiple times. You could create categories based on, I don't know, the computing time. Could categorize whether the request is going to hit the database or not, for example, and how many of them are there at the very specific time, because when you're doing the sampling. And this could be more interesting data. You could enhance the data set like that, and then you could get more really interesting features, and the predictions could be much more precise.
So fine. So we have the GBM for predictions when the server breaks down, or you can predict the load of the server. Then we have the isolation for to detect anomalies with MicroProfile-like metrics. What else could be interesting for Java developers? Or not interesting,
all of it.
Rather than I know it, but the example with airlines is a nice one. So do you have similar examples for different algorithms where you can?
Actually, you can. The airlines is a pretty standard data set used by teachers all over the world to teach predictive statistics, and you can use many algorithms on that. So this is not restricted to just tree-based algorithms. You can. It depends what you want to predict on the data set. You can use normal, simple regression, and that's it.
How many algorithms in total are you implemented with H2?
Over 10 right now.
So which are they? So we can go briefly. So we have the isolation, the GBM. So what is the next one?
Then we have XGBoost, GLM, naive.
What I say? Slowly. So the next one, what was it?
GLM.
GLM for what?
That's basically regression.
Okay. For what would be useful? Let's say we have log data, let's focus on Java EE domain. So in Java EE, what we will get, we have all the metrics from application server. We could, use the log files, or let's say we could also access a database with...
It could be useful for the very same prediction you mentioned to predict the time when your server or your Java EE server will fail.
Okay.
Crash.
And
it could also be used for that.
When to use GLM and when to use GBM?
That's a really hard question with not so simple answer, because it's mainly about knowledge of the algorithm, which I don't have a detailed knowledge of both of them. We usually have dedicated people to develop it, but GBM is more explainable because the output of it is a decision tree, and you can view it and you can actually see how the AI makes decisions based on the data.
Okay.
So you can walk the tree. And this is one advantage of GBM. So if you need maximum explainability, then you would use GBM.
Hmm? And the GLM, so what you get out is just the answer, yes, no, or whatever.
Yes, you get the answer, yes, no, or the number, the predicted number, or anything else.
Okay, so the next one is? And
The
for,
next
you
one
know what GLM stands for?
Yes. GLM or GBM?
Both. The GBM. So what is GBM?
Yeah, GBM is gradient boosting machines, and GLM is generalized linear model.
Okay. Next one.
Next one, did we mention XGBoost?
No.
Okay, so XGBoost is I believe, formerly Chinese project. It's a product of some academia research in China. And what we do in H2O is that we only provide, Java bindings to the library. We actually contribute to the GitHub project because XGBoost is also open source, so anybody can have a look. But it's written in C, so it has a JNI bindings, and what we do actually, but H2O adds much more on top of it because you can do the feature engineering with H2O. XGBoost itself is just another way of creating decision trees, a pretty good way, but it lacks some features. And if you wrap it with H2O, then you get all the features of H2O, and then we just call the XGBoost for you.
So for what XGBoost is useful?
It's the same as GBM.
Okay. And what is
same use case, not same algorithm.
Okay. And the algorithms I would choose depending on the data quality, data size, and this is...
XGBoost has one big advantage, and that it works on GPU very well. It was designed with this in mind. So if you can transform your data properly, which H2 will take care of mostly, then you can run this algorithm on GPU. And the result is also a decision tree.
Okay, cool.
Yeah, but it's basically what's the difference between GBM and XGBoost is how the numerical stuff works. It's about optimization because GBM is ultimately slower, but there are many versions of GBM. For example, there is light GBM, which is also very fast on CPU, but XGBoost mostly it's parallelized on GPU. When you can parallelize the training phase. And if you have a data that's suitable for the parallelized training, then you get a lot of time advantage.
Cool. And so this would probably explain why it's in C, because it will try to access, the GPU driver, right?
Yes.
Okay.
Exactly.
And but you could also do it with Java, right? With the NIO, you could actually access the GPU as well, right?
You could do that. Actually, XGBoost is not originally H2O project, despite we contribute to it right now. So the decision was, for some reason, made like that.
Mm-hmm. Okay. No, I just interested in the what's behind. So
yeah, but it's perfectly possible in Java, I believe. Never tried it myself, but it's possible.
My brother tried. So my brother just did a lot of stuff with the 3D and Java, and he accessed everything from NIO. So this is why I know it. Memory map buffers and other stuff.
Java has excellent OpenCL bindings, so something like that could be done. I'm not sure about NVIDIA, so I have no idea what's the status of that.
Mm-hmm. Yeah, my brother wrote once even an editor of the CUDA stuff. in Java, so in NetBeans plugin back then.
So it's probably perfectly possible.
Yeah. What is the next algorithm?
The next algorithm is word2vec.
Okay.
I would say just pick one, and this works. Put it really simply, you give it an input text, and it will create vectors out of the data, and it will basically compare. Then you can do some math on top of it. You can compare how distant the vectors are, what's the angle between them, among them, and then you can predict. For example, you can evaluate comments on your blog, whether it's toxic or not.
Yes, and this is also part of Elastic. I think Elasticsearch has also the L2vec and Hibernate Search, I guess, both. You could do, they have both Word2vec included, right?
Well, yes.
No, just because I use them already, and we used to, I think, to find similar text pieces or something for search with Word2vec. And Word2vec is also, I think, there's a famous example with the king and I don't know. This is the distance between words is measured in vectors, right? Something like this.
Yes. So you represent the set of words as a vector, then you do the math.
Yeah. Cool. So this also included. So I would put the API of the algorithm looks like you get a string and what I get back is a number, probably, right?
Yes, exactly.
Actually, the string you need one string is a database of strings, and then the string which relates to the database, and then I get a number back, I guess, something like this, right?
That's one way to represent it. Or if you use H2O, then the output would be much more human readable.
Cool. Okay. So this is what I also can imagine. So it's the next algorithm then.
For example, of course, we have neural networks. So we have deep learning.
Cool.
Which is also usable for almost all the use cases we have mentioned. Only, again, the algorithm works really differently. You have a set of inputs, which might be all the features you have. Depends on you, depends on how you set the algorithm. And then you have one output, the prediction.
Mm-hmm. And how it works behind the scenes. So if I feed you with the data, are you generating code behind the scenes, or how the model is captured? Because my understanding is I have to train the model, and then I have the model, which is usually code, and then you can use the model, right? So there are like 3 phases. And so what happens? So do I get in-memory representation, or do I get source code, or what is my model in H2O?
You get, in the very first phase, you mentioned really correctly that you have these 3 phases. There might be more. You load the data into H2O, then you train the model, you see some statistics, the performance of the model, then you can validate it. And at the time, the model still exists in memory, in H2O. And you can download it or export it, and then re-import it into H2O again. And what's really cool is that you can export archive. It's actually a zip archive that's directly usable in Java.
Yeah, so you can. Cool. So you get a jar, more or less, and I can just include it and then use it like API without caring about the whole AI stuff. It's just an API.
Yes. Basically, that's the main use case, or one of the biggest use cases in the companies, because you have a data scientist and you have experts on one domain. I don't know, for example, insurance, which is something I don't know anything about, for example. And imagine you're the engineer in the company and you have this insurance expert who has been studying for 5 years and then doing it for, I don't know, another 20 years. So he or she is a real expert. And she creates the model, verifies it, and then she just gives it to you. And I will just call predict from Java. And I get the prediction. And so it's a black box to me.
Yeah, actually, so in real world, it would be like there's one application which creates the model. It will be a standalone application, mainly driven by experts. And then the application at one point will output the model, which could be checked in, let's say, to Nexus or whatever. And then we have our pipeline, which will check out the model, include it to our application, just test it, and this is our app, right?
Yes, you can actually interchange it on the fly if you want to. If you want to do it, no problem. You don't need to restart it.
Mm-hmm. So Yeah, so we can, of course, we can use, we could feed the model with which is a little bit boring, but we can, feed it with proper metrics. So I mean, metrics of a system which behaves correctly, and then show what is not correct. So we can use for categorization, right? 2 buckets, like
Yes, that's the perfect use case.
Yeah, so we can use that. Also interesting. Okay, so what is the next one?
The next one would be. Well, we have a k-means, which I honestly don't know how works precisely. Been around for quite a while, and I haven't implemented it. So,
but you know what it could do? So in theory, so this k-means is also the same with different features, or
actually no, k-means is unsupervised learning, I believe, and I have no idea what it does, how it does it. So
yeah, but unsupervised learning would mean it would try to find the answer without the learning phase, right?
Yeah, no, there is always a learning phase, but without a teacher.
Without a teacher, right? So you give him the data, and then it learns, and then at the end knows what to do exactly.
Hopefully knows, but
yeah,
that depends on you. Actually, there are lots of parameters, and if you set them correctly, then it will probably know. And if you don't know what you're doing, then it will probably fail. So that's what the driverless AI tries to automatize.
Yeah, and this is always the case. So what usually happens is you have to, to use a lot of functions and know about the algorithms, so cleaning up the data, and then you should look at the result, and then you decide, is it okay or not? Is this less exciting as one might think with the whole AI? Is more like statistics on steroids, right?
Yes, it's all statistics. It's predictive statistics on steroids, and it's not just, before you even do the prediction, maybe you should, it's a bold statement, always check the data, check all the features, what's the distribution, how the data looks. So this is also possible in H2O. And then you do the predictive statistics. And it's also a lot about numerics, the numerical optimization inside the code.
Mm-hmm. Cool. So we have k-means, which is driverless or unsupervised learning. So the next one.
No, driverless and unsupervised learning are two distinct things.
I thought the driverless is yeah.
You actually mentioned that k-means is something that will produce something without the learning phase. So yes, there is always the training phase.
Okay. No, I meant driverless. This is what I said.
Driverless is the other project.
Okay.
And it automates the earlier parts like feature engineering, etc., etc.
Mm-hmm. So driverless is your commercial project.
Yes.
Yeah. What I meant, the unsupervised learning with k-means. So what is the next algorithm?
Isolation random forest, which is also unsupervised, and this is the newest algo we have.
Cool.
I also wasn't implementing it, but this one is useful for the outlier detection you mentioned. So you can detect anomalies in the data.
And this is newer, so it means it is faster, better, or what is the distinction to the first one?
Actually, the k-means, the first one, is not aimed towards outlier detection. So for this, we really have the isolation forest. So this is the main point of adding it. It's not faster, but the main point of having it is the outlier detection. If you want to do it, then you want isolation random forest.
Because we mentioned at the very beginning an isolation algorithm. I think it was ALB, right? And there's the next one. Isolation forest. So I already mentioned one. So we started with an isolation algorithm.
Yeah.
But okay, so now this is the newest one, and this is outlier detection, like when to detect when the system breaks, for instance, what is normal or what is not normal. Okay, this is the last one.
No, actually, what we have is 2 more interesting features. For completeness, let's mention the naive Bayes algorithm, which is not really used in real world. Because you called naive because you assume there are no relationships between the features, etc., etc. So it's usable. For example, you always ask for the examples. So really simple spam detectors use this naive Bayes.
Mm-hmm.
So this is how it works. Then we have stacking. And we have AutoML. And this is really interesting. Those are two, it's not algorithm. It's about combining, the stacking is about combining the models into one that's maybe depends, more powerful than just one model. So you can, for example, create a GBM, gradient boosting machine model, which is based on a decision tree. And you're not satisfied with the results in some areas. So you might create another model for any specific reasons you have, for example, with GLM, because you know it will perform better in some areas, and then combine those two together, and H2O will create a stacked model that will just use both for prediction. And the combined prediction is hopefully better than the outcome of just one algorithm.
So stack models, like, this is the composition of different algorithms, right?
Yes.
So, and this is also open
models.
This is also an open source part. So
yes, this is also part of the open source part.
Very cool. And okay, so we had the stacked and the biased. How it's called? Biased. What do you say?
Naive bias. Actually,
naive bias. Naive bias. So which is not usable because there are no relation, or not that usable in the real world because there are no relation between features. And then we have the stack, which is composition of different algorithm. So what is the next one?
The next one, it's a really cool feature. It's called AutoML, and we have a separate team just for that, just developing that, because this is basically open source driverless AI. It doesn't do all of the features driverless AI does. For example, the always mentioned feature engineering is not there yet, but this will, how it works from user's perspective. You load the data into H2O, just give it to AutoML, and you say, I want to predict this and that, and that's it. You don't have to set anything except for the maximum time you want to wait for example, because there has to be some limit, which by default is an hour, I believe. And then it will run, and it will try different combination of features, and it will try different models and compare the results, validate them, and then you get a model which should perform really well. So it's automated.
In which form would I provide the data? So let's say let's do something practical again. So
we have a lot of connectors. You can use plain CSV, which we, by the way, have a distributed parser for. That's a really cool feature because you tend to have. The reality is customers have really big CSVs. Yeah, like gigabytes of data. You could use any database that has a JDBC driver. You could use Amazon S3. You could use Google Cloud Storage. That was actually originally Google Cloud Storage connector. Sorry for the off topic. Was community contribution on GitHub. Just had to polish it a little bit, but anyone is free to contribute to H2O.
Yeah, cool.
So this was a contribution from one of our users. You can, of course, load from your local, TXT files if you feel like it. Then we have Hadoop file system connectors, integration, of course. That's
so what would be the simplest possible use case with simplest possible SQL table as input and the outcome? So I'm just searching for a simplest possible example so that the listener could do something.
I believe I might have some examples, and but there is no simple answer when it comes to the API, because you can use R, Python, or we have a website interface to it. So let's say you choose the website interface. So then you just run H2O on your local machine. You just download it. It's a jar. So it's really simple to start with. You don't need a cluster. Definitely. And then just once you do Java jar, H2O jar, it will start itself, and it will give you the address of the website, and you just click it. The website opens, of course, and then there is a button called data on the top of the website, and you just choose import, and that's it. And you write your SQL statement inside, and it will import it.
Okay, this is also okay. What I meant is rather, let's say, forget about the user interface. It's just what is the interface to the data. So let's say I have a table with 3 columns, So give me a simple example. What could be the columns? So it could be, let's focus on the application server. I can say, I don't know, method name and processing time and memory, consume memory. This is what we could do. And we have millions of such records. So what I will also need the outcome. So I will need to have to know this is the input and what I expect as outcome, what I would like to predict. You know what I mean? This is how the whole process would work. So I have a table with data, and then I need somehow, the result to present to AutoML the result. So how
the result of the training phase, correct me if I don't understand you correctly, but the result is the model, actually. The result is not saved into the database. You pick the features. You said you have hundreds of columns. So you can just select the ones you want. For example, the memory usage at the time, or the type of the request, the categorization we have been.
So you have 3 columns and 100 of rows. So I have 3 columns is like method name, let's say execution speed, and the last time memory execution. There's a memory consumption. So I have 3 columns, which is just like the statistic data of our application server, right? So this is
yes. Okay. So then you just write your select statement.
Yeah.
Select the 3 columns from blah, blah, blah.
Yes.
And then you can do H2O AutoML command, or you can just click it. And then you will need to specify the predictors.
Mm-hmm.
So you name the 3 columns again. Then you specify the response column. That's the thing you want to predict.
Okay. So successful or not properly, right? So this would give just Boolean. So very simple.
Yes, if it's binomial like that, then you of course, that's correct. And then it really depends on the algorithm. If you use AutoML, then that you can leave everything to default and just make it happen, make the magic happen. If you use some of the specific algorithms, then you can specify, for example, for GBM, let's pick this one. You can set the maximum number of trees it will create, the maximum depth of the tree, and then you can fine tune it. But you can leave everything to default. Yeah. So the minimal use case would be just that.
Yeah, but actually, if we expand it a little bit, it could be already interesting. What we could do is to provide a broader table. What I get is like, my architecture, like the facade of the boundary, name of the method. Then I would get performance of the method. I would get memory, not sure, because if I would just capture the logger, there would be no memory. But then what I could do is I could also see, exception happen or not. So this would be Boolean, true or false. Yes. And then also which probably...
Or you could categorize the type of exception. It's better to capture the data in all the colors.
Yeah, and then probably I will need to know a little bit more, because this is just the outside. I would like to see which other methods were called. So this will be really valuable data for the production. Otherwise, probably nothing will come out. But with that, this will be like, just capturing the logger information. So if I would have a logger which outputs CSV, so I will already load it to your system and predict, or see which inputs are problematic for the server, right?
Yes, this is perfectly possible.
This is interesting. So this is somehow which I can imagine as Java developer.
Yeah, you would have to label the data for GBM, of course. So you would have to go through the data, and naturally you would have the information whether it is problematic or not. This is what I mean by
because if exception happens, it is problematic, right?
Yeah, then you have the label, so then you can use this supervised learning stuff and, for example, pick the GBM you've been talking about, and since you have the response, there is no problem. You could do that.
But I could also use the AutoML for that, so I don't do nothing. I would just say...
Yes, what AutoML will do is to try many of the algorithms we have, and one of them is GBM.
So how many rows of data, so how many log statements will I need to have a reasonable result?
That depends on how many features would you have. Not only, but at least, 30 observations per feature. And if it's a categorical feature, then you have it depends on the cardinality of the domain. If you have a
for me, it's just will is it successful or not? It's just very simple statement. So
but you have a lot of features, and for example, let's assume you have a category of request, and if you have 10 categories, and you want to predict whether it's problematic or not, then per each category you have to have at least few observations. You cannot have 0 observations. You cannot, if you have 10 categories, you cannot have 5 rows in total.
So to be concrete means a category could be a method name. So for every method name, I will need at least 30 observations, right?
At least, I wouldn't say at least, but that's my rough guess. You need, actually, it doesn't really, I don't want to say the more the better, because that's not always the case. At some point, more data could actually hurt your model, but hundreds is okay.
Okay. So this is actually an interesting case. So we covered all your interesting algorithms.
Yeah, we do have some more minor algorithms, but let's not go over them.
Yeah, but what the listeners can do right now is to go to H2O. They know the algorithms and check out the Maven module and try experimenting, right?
Well, we use Gradle in H2O, so
yeah, Gradle is the same. So just use the Gradle module and start experimenting, right?
Yes, if you just clone it, there is a really nice README. Actually, if you want the test, some of the JUnit tests need some data to run. Because machine learning is all about data, and you can use a Gradle task to synchronize it locally. It has, 100 megabytes maybe. I'm not sure. So we have a small data set just for the tests, and that's it. And then you can start.
Yeah, cool. So you are in a really interesting project, in Prague, involved in a startup in Silicon Valley, and yeah. The only thing, is there any Java involved? JAX-RS, you said it, right? There is a JAX-RS endpoint. And
yes, kind of, but we have our own serialization on top of it. So mostly servlets. We use Jetty internally.
Cool. And what's the next steps? So what you are planning, or what is your one of the coolest project you heard about and you can talk about with H2O and Java?
Coolest? You mean like sub-project? Because this is all I do right now. But
real world project. If you think about I don't know. So if I spend time with technology, I always think what I could do with it. Now.
You mean the real world use cases?
Yeah, real world use cases. So what was the coolest one?
Yeah, we do have conferences. It's called H2O World, and on these conferences, I usually stand at the booth, and you get to talk to so many interesting people. But the stories that really touch me the most are the healthcare applications.
Okay.
If you can, for example, predict cancer and save some lives, then that's the ultimate reward for me.
Yeah. The cancer prediction is actually in AI already better than the doctors can do, right?
Yeah, I heard about some applications in China which are really successful. But it's not just healthcare. Healthcare is obvious. I met a guy in London, and he's using AI to preserve some wildlife animals. Cool. And he's not the only one, actually. There is other guy in London which is interested in spiders. And some small animals, and he uses AI to categorize them and basically making their environment better.
Okay, it is actually a cool story. So
and you have to be besides being a data scientist, you also have to be an expert on the domain. So obviously, I don't know anything about spiders.
No, sure. But what you should do, you should send me links to the algorithms on the H2O. I will put it to the show notes as well, your university. So I will put it to the podcast. So
yes, we do have a really great documentation. It's not just the documentation for the sake of having one. We really have a good documentation with the explanation of each algorithm. And if you want to go deep into the math, how each algorithm works, then we also have that. So
yeah, cool.
Just docs.h2o.ai, but I will provide the links as well.
So thank you. And where the people can find you on the internet? GitHub, Twitter, blog? On
GitHub and on Twitter, basically. And I have a blog. which is pavel.cool.
Hey, cool.
Yeah, that's really cool. You know, my German last name is really complicated, so just use that and it works.
Yeah, cool. And pavel.cool and Twitter?
Twitter is actually my full name. It's Pavel Pscheidl.
Okay, perfect. And do you miss a little bit of the Java goodness in your project right now?
Actually, I do have a projects at the university, and sometimes I do miss it. But H2 is mainly about algorithms and low-level stuff. So sometimes when you write yourself a nice API really quickly, we do have some active projects at the university right now. One of them is actually closely coupled with statistics.
Okay.
And we call it a cloud calculator, and it will predict your cloud costs based on many inputs.
And this is a Java E MicroProfile project?
This is Java E8 MicroProfile project, and we do gather the inputs via REST API, and we pump it into actually H2 directly.
Okay, so listen, we are now late, but I will have to re-invite you and just talk exclusively about the new, H2O University MicroProfile Java E project, because now we have the basis of statistics AI a little bit, and then we can talk about your university project, right?
Yes, sure. I would be happy to do that.
Okay, so thank you, and see you probably at Java user group or at the university if you like.
Yeah, of course. Thank you for inviting me. Thank you for having me, and see you hopefully really soon.
Bye.